Okay. And then just to be, I didn't even get, oh yeah, okay. So these are a few questions from the latest past paper. The past paper in question being 2023, right? So first things first is that this question is asking about proofs. This kind of proof is one that CAPE doesn't often ask, which is counterexample. The most common one that they have is principle of mathematical induction. So this one is a counterexample. It says if X and Y are negative real numbers and Z is a real number, then we want to prove that a statement is false. Whenever a statement you want to prove a statement is false, oftentimes a counterexample. So to do a counterexample, you just need to find any value of X, Y, and Z that would be incorrect. So we're going to start with let X be -1 and Y be -3. The first part holds true, right? X is less than Y, which is negative. X is greater than Y, right? Which is -1 is greater than -3. That part is true. Now Z can be any real number. In this case, we make Z be 0, and we notice that this is an issue because X times 0 is said to be greater than Y times 0, but 0 can't be greater than 0, so it's false. So that's an example that proves that this statement that they gave us is false. This question now is talking about dividing a polynomial and getting remainders and not getting remainders sometimes. For this case, this is also a part of module 1. This is about factor and remainder theorem. Factor theorem is really just saying that if you plug in a root into the function, you'll get the answer of 0. If you plug in any other value, then you'll get a real number. That real number will be the remainder. So if it says that this function is divisible by 2x minus 1. The first step is to find out if 2x minus 1 is divisible, then we're going to use factor theorem. And we're going to rearrange 2x minus 1 and equate it to 0. That means x has to be a half, right? And we're saying that when we plug in a half into f, right, we're going to have 0 as the final answer. So when we plug in a half, right, we're going to get 0 as the final answer. In this case, 6 times a half cubed will be 1/8. And then p times a half squared is going to be 1/4. And similarly for q. We do that and we finally get one linear equation, p plus 2q equal -10. We're going to do the same process, but this time for remainder theorem, because it says now it has a remainder of 2 when it's divided by x minus 1. For x minus 1 to be 0, then x is 1. So we're going to plug in +1 into f, and we should get 0 because it's... No, we should get 2, right? This right here is not supposed to be 0, it should be 2. So when we plug in 1, we're going to get 2, the remainder. We continue the process, and we have a linear equation. Now we have 2 linear equations. And if you have a proper calculator in the exam, which I recommend you should have a powerful calculator, one that is able to factorize, one that is also able to solve simultaneous equations, because these are very trivial things that you learn in AdMaths, as well as you might learn this in CSEC maths, right? So they might not be marking for that. You might just literally just say, solve simultaneously. And the moment you solve it simultaneously and you get an answer, you get a mark for saying solving simultaneously. So they don't want to necessarily see your process for solving simultaneously. This is something that everybody already knows how to do at the CAPE level. It's about, did you apply remainder and factor theorem? This question is about logarithms, right? It says that you need to solve this logarithmic equation. The first step is that the first thing I realized, that without even looking at what the question asks, is that I realized that x squared minus 9 is the difference of two squares. Oh, the calculator I recommend. I have a calculator. I'll take a moment to look for the official name. Okay, so the calculator that I have is called a Casio FX-991EX. Sent in the chat. It's a calculator that I use for both AdMaths as well as pure math, right? And it's able to do a lot of the things that you learned in AdMath, and you'd never need to do it again in pure math hand by hand. There's no reason for you to be factorizing something slowly or trying to solve a simultaneous equation on your own. Remember that the pure math test is pretty much a speed test, because if you look at the marks and the time you're expected to complete things, it's a mark per question, which means that if you are spending 9 minutes on a 6-minute question, you are actually behind, especially if you want to check over your work, right? So having this calculator is something that you should definitely invest in. The places that sell the calculator, I don't actually know. I got this one from my school at JC, where the teacher was a great math teacher, and so he recommended this calculator, and we bought it from him. Okay, so for this question, logarithmic equation, the first thing we do is that we realize we have to remember one of the first rules of logs, right? If they have the same base and we are subtracting, then we can actually turn it into division. So now we have log base 3 of the first expression divided by the second expression is equal to 3. Remember, originally I told you the guys that the first thing I saw when I saw x squared minus 9. Hello? A question? Hello? Okay. So the first thing that I realized was that this is the difference of two squares. So immediately I broke it apart to x minus 3 and x plus 3. One of the things that you can often do with CAPE is look at patterns. If you see the difference of two squares, you should probably break them apart. If you have the multiplication of two squares, you should probably put them together. There are always patterns that you're expected to follow. They will not ask you a question. We're going to have an answer of like 1.81345. Like that's just not an answer they want to give you. Of course, it's possible, but it's not something that you would often get. So you'd often have perfect squares, difference of two squares, or easily factorable equations. If it's not easily factorable, it's because they don't want you to solve it. Because it's another example is whenever a question is talking about roots of an equation and tell you to find a new equation from it, they don't want you to solve the equation, so they will actually make the roots don't exist. Okay, so I broke it apart. And then the next step after breaking it apart is realizing that you need to divide out the x plus 3. Now we only have log base 3 of x minus 3 is equal to 3. Now we know that switching from log to exponential form is just to have the base of 3 raised to the power of 3 is equal to what is inside the bracket. So we have x minus 3 is equal to 3 to the power of 3. That means x minus 3 is equal to 27. Final part, which should be super easy, is that x is equal to 27 plus the 3, x is equal to 30. This solution would give you only 1 mark, as in x equal 30 is only 1 mark out of any amount of marks this question is worth. I'm going to assume that question is likely worth maybe 5 or 6 marks. And it's about, did you use the rules of logs? They ask, did you use the rules of logs of having minus become division? Did you realize the difference of two squares? Did you know how to change from log form to exponential form? And then now I want to look at function, right? This is also from the past paper. It's asking about proving bijectivity. So in CAPE, if it has a function question, it's likely going to ask you to prove either injective, surjective, or bijective. Bijective is if it's injective and surjective. So I'm going to try to explain injective and surjective for anybody who has not had that experience, right? So the way to think of injective is if I got two results, so I plug in A and B into a function, if I plug in A and B into a function, right, then that means that the function, one more time, say, okay, this is what I'm going to say. Whenever I plug in an answer into the function, I should get only one result, right? This is the same thing as if the expectation is that I should not plug in an answer, right, and get an answer that I could get from something else. If I plug in 1 and I get the answer of 5, I should not be plugging in 7 and getting the same answer of 5, right? So the way that I prove injectivity is to simply write the same, f of A is equal to f of B. That implies that A must be B. A cannot be any other value but B. So the first part is when you're proving anything is that you need to start with the left-hand side. I set the left-hand side of f of A equal f of B. We plug in A and B into the function. We subtract minus 2 from both, and then we divide both sides by 7. Right? And now we have A is equal to B. So that's the right-hand side. So we move from the left-hand side to the right-hand side. Now, for surjectivity, that's us really proving that this function has an inverse. Think about it this way. We're just proving that the function has an inverse. So for f of x is equal to y, we just need to solve for x. And we look at it and we say like, okay, will any value of y give us an error? In this case, no matter if y is 0, negative 11, 5, or anything in between, because y minus 2 divided by 7 will always give us a real number, then that means this function has an inverse, which means that it's both injective and surjective, which at the end means that it's surjective. This question says that...
For the next question, for me, please.
I'm sorry, repeat, please.
I just wanted you to go back to this next question. Thank you.
This one. Okay, so do I need to explain it again, or are you just writing something down?
I was just writing something.
Okay, no problem. So another way I think I can also, to be clear, even though I did a lot of math part for this question, you could also just explain what injective and surjective is in the case of this function, and you get your marks. So for example, for surjective, right, I'm really just proving that it has an inverse. You can say all linear functions have an inverse. Therefore, f of x, which is a linear function, must be surjective. You see that? So I didn't even mention anything about equal signs or having any math, but it still works out because all I did is explain what surjective is and explain that I know that all linear functions will be surjective, and so f of x must also be surjective. Cool. Are you finished writing?
Yes, sir.
Okay, so in this question, it says that given g of x, right, which is a function which has division involved, they are asking to prove that g inverse of 2 does not exist. So to do that, all you have to do is just set it equal to 2 and try to find your answer. So in this case, right, I set it equal to 2, and we bring the x plus 3 to the other side of the equal sign. We have 2x plus 3 equal 2x plus 6. If we realize that 2x is on both sides, we can subtract 2x. We have 3 is equal to 6. We realize that 3 is equal to 6 is a statement that we are fully aware of is completely false. And anytime in math you have a statement, after you work it down, you have a statement that is false, that means whatever you started with is impossible. That means the very top part, which is 2x plus 3 divided by x plus 3 equal 2 is not possible, which means that there is no x value that can give us the answer of 2, right? So there's no solution, which means it does not exist. This question is, I want to take this one. Okay, this question was just saying, it says, what you do for a question like this is, yes, that works as well, right? So you could also just find the inverse itself of the function, right? If you plug in the value of 2, you would also realize that it doesn't work. The way that I did this is without finding inverse. The reason I did that is because the question before this, I basically found the inverse, and I wanted to show you guys different way of approaching everything. But yes, the expected approach that most people will have is the expected approach is to just find the inverse itself, plug in 2, show that the denominator is 0. The equation of this one, D. Okay. Okay. So that was us just taking a quick look at the last of past paper. So this is how we're going to tackle questions every time I have that chance, okay? So now this is where I kind of step back. So that was a lot of me explaining my thought process, how I'd go about any question that I see. And now I want to do something similar, except this time I'll be doing the questions alongside you guys. So these questions are not CAPE questions. I teach a class, and so I would make questions to be used with my students that are oftentimes more difficult than CAPE. However, for the actual CAPE, for the actual preparation for CAPE itself, are often the same level of difficulty. I want to take a look at this question 8, right? Where it asks about bijective. I want to take a look back, right? Which is when you have a domain and the codomain, right? In this case, we are asked to prove bijective. So the first step is to just prove injective, right? Which we remember is us saying that if we plug in A and B into a function, then if we plug in A and B into the function, then we know for a fact that A can only be B, cannot be any other value, right? So all I have to do is start with the left-hand side, which is that f of A equal f of B. We get A minus 2 over A minus 3 is equal to B minus 2 over B minus 3. We are going to expand by multiplying the top by A minus 3 and B minus 3. So we're going to have A minus 2, B minus 3 equal B minus 2, A minus 3. Expanding it out, we have A, B minus 3A minus 2B plus 6 equal A, B minus 2 minus 3B minus 2A plus 6. So this 6 cancels this 6. This AB cancels this AB. And then we have minus 3A on one side. Bring this over to be plus 2A. We have minus 3B on one side. This over to become plus 2B. And now we have minus A is equal to minus B, which is the same thing as A is equal to B. So now this is the right-hand side. So we just proved that it's injective, right? Any confusion about that part? No confusion. Okay. The next part is to prove surjective. So if we're going to prove surjective now, what we're going to do is we're going to prove that the inverse is there. However, we have to look at the domain and codomain and the range, right? So in this case, it told us that this function, the domain, the values that you can enter for x, is all real numbers minus, which means except the value of 3, right? Similarly, it says that the output will be all real numbers except 1. So when we're finding the inverse, right, we just need to show that they were not lying. When we find the inverse, we are going to get every value except 1. Cool. So we're going to have f of x is equal to is equal to x minus 2 over x minus 3. Cool. Now we're going to have this being y, right? And when you guys are finding inverse in CCK, they tell you to switch out x and y. So you get x is equal to y minus 2 over y minus 3. Okay, we're going to multiply and solve for y. Okay, so we're going to have y minus 3 times x equal y minus 2. We're going to have xy minus 3x equal y minus 2. Yep, okay, and then we're going to have xy minus y equal 3x minus 2. Factor out the y, we get x minus 1 equal 3x minus 2. Y is equal to 3x minus 2 all upon x minus 1. So, look at this, right? What it's really saying is that we have this right here, right? Now, we just need to explain that x, this value here, can be anything except 1, right? We can get value of x, we can plug in any value right there, except 1, which is what they stated here, right? They said, at the end of the day, we'll get any answer except 1. Since they said that, right, what we found out what they said match, we can tell them that, yes, it is injective. So sorry, it's surjective. So we have injective to be correct. And because what they said is true, which is that we can get all real numbers except 1, surjective is also true. So since surjective and it's injective, it is bijective. Cool. Any confusion? No confusion. Cool. Find the inverse of f of x. This is the same thing as here. Okay. Um, um, yeah, cool. Okay, that was here. Okay. Okay. So, seeing my screen, yes. Okay, so I want to take a look at some more questions because that's what we're doing, right? We're just doing so many questions and then I can give you your own questions. Also, it's very important that if at any point you feel like you don't understand a section, you should definitely speak up and I will be sure to clarify. Cool? All right, so yeah, okay. So the question gives us a fraction minus 5 and tells us that it's greater than 0, we need to find x, right? The first thing we're going to do is that we need to change the fraction and a number to be a singular fraction. So it's by finding the least common multiple for the denominator. In this case, you have to use x minus 1 since that's what the fraction has. We're going to have x minus 1 as the denominator, and we need to multiply -5 by x minus 1 to get the numerator. 2x minus 5x will be -3x. Minus 3 minus 5 times -1. So this -5 times the -1 becomes +5. That's -3 plus 5 is +2. Are we saying that this is greater than 0? Now we need to remember our rule, right? If we have a fraction, a over b, if we have a fraction, a over b, right? Then one of two things. We either have both a and b being greater than 0, it means if a and b are positive, right? Imagine 2 over 1. We're going to have a positive number at the end of the day, right? Similarly, if we can also have both a and b being negative, right? Because we had -2 and -3, dividing a negative by a negative will also give you a positive number. So we're going to look at only when both of them are positive first, right? If they're both positive, we're going to set the numerator and the denominator to be greater than 0. So we have -3x plus 2, and that's greater than 0. If that is the case, then x has to be less than 2 over 3. But simultaneously, as that is happening, x minus 1 also needs to be greater than 0, which means that x is greater than 1. If we look at the number line, we're saying that x needs to be less than 2 over 3, and it also needs to be greater than 1. You see that don't really make sense, right? Like, there's no number that is less than 2 over 3 and greater than 1, which means that x doesn't exist. There's no real value for it, okay? And then we can look at the second case, because we have to look at both cases, because remember that a and b can be positive, or a and b can both be negative at the same time. So if they're both negative, we're going to set them both to be less than 0, which is what being negative means, right? We're going to solve it. So solve both inequalities. So if -3x plus 2 is less than 0, then x is greater than 2 over 3. And if x is greater than x minus 1 is less than 0, then x needs to be less than 1. So now look at the same graph again. But this time we have to draw what the new solutions are. So we have x is from 2 over 3, we're not including it, up to the top, right? And we also have x is less than 1 going all this way. We're going to realize that the solution kind of need to be they both need to be correct, is everything between 2 over 3 and 1. So we have x is a member in the set of 2 over 3 to 1. We realize the round brackets are important because if it is a square bracket, that means we're including that value. But realize that we said that it has to be greater than 2 over 3. It means that this round bracket is saying that go as close to 2 over 3 as you want, but do not plug in 2 over 3 itself. Now that we have these two answers, one on this side and one on this side, we need to combine them. So x is, this one is empty, and so x can be nothing, as in not zero. It cannot be zero, right? It's empty. It has no value. Or x is between this range. So we just write the final answer being x is from 2/3 to 1. You can realize that I wrote it in two different ways. Both ways are correct. If you answer either way on Cape, you would get the answer. You get your marks for the answer. Any confusion about that? Okay. This question now is about modulus and quadratics. So, okay, good. So this one says we need to solve x squared minus the modulus of x minus 12 is less than 0. There's two ways to solve this, but I usually solve it this way, where I'm going to say, recall that if we take the square of the modulus, it's the same thing as just taking the square of x. So you're going to replace x squared with modulus of x all squared. Now we have this, right? This kind of looks closer to how a quadratic looks. So remember earlier, this is not a quadratic exactly, at least not the regular way that we see it, because this is x, but this is the modulus of x. Now we both have them as being modulus. So the first thing I'm going to say is that I'm going to replace the modulus of x with a. So now we have a squared minus a minus 12 is less than 0. Now we're getting into the things that we know how to do, which is solving a quadratic. So now we factorize it to have a plus 3 and a minus 4 is less than 0. Now, this is not a quadratic equation, it's a quadratic inequality, which means that we have a less than sign, not an equal sign. So we can't just be like, okay, is these values and we move on. Instead, we actually have to draw the graph. So for the graph, we know that the roots is -3 and 4, right? Also, we realize that the value in front of a is a 1, as in a is positive, which means that a squared is positive, which means that this graph has to be smiling. So it's a smiling graph passing through -3 and 4. And it says that we're looking for less than 0. So wait 1 second. Okay, so I have this graph backwards. I have less than 0, but I accidentally picked everything that was greater than 0. So correctly, I should not be looking at the part that I am looking at. I should be looking at this section, the in-between section that I should be looking at. So what this should have been is that A is between this range, right? I'm going to continue with this, but do notice that the answer that I have here is incorrect. Incorrect in that it should be everything else except this, okay? So if we had A is less than -3, then the modulus of x is less than -3. Can the modulus of a number be less than a negative number? No, the modulus will always be 0 or a positive value. So this part is impossible, right? If a were greater than 4, then the modulus of x will be greater than 4. If modulus of x is greater than 4, then we're really just looking at every value from less than -4, less than -4, and greater than 4. Now, I need to repeat again. The graph that I drew here is wrong in that we looked at the wrong, I looked at the wrong part. I looked at greater than 0 when I should have been looking at less than 0. So it's this section. So the answer that I have here, which is less than -4 and greater than 4, should be the opposite. So the actual answer should be -4 to 4, not including themselves. Okay, so the answer should have been written as x is in the range of -4 to 4. Cool. Okay, looking at a similar example about inequalities. This time there is no modulus, however. The question says that we have 4x squared minus 2hx plus 8 minus h is equal to 0. They're saying that the roots are real and therefore you should find h. We have to remember back in ADMATS, additional mathematics, where we had the discriminant, where the discriminant is determining whether or not a root is real, imaginary, or equal. So if it's real, it can either be 0 or it needs to be greater than 0. So we have this new inequality to solve. We're going to plug in each of these values. So we have b is this section minus 2h. We square that. We have minus 4 times a in this case is 4. The c is the constant here, which is 8 minus h. And that's all greater than or equal to 0. Remember, the reason I have greater than or equal to 0 is because it says all the roots are real, which means that the discriminant has to be 0 or a positive number. Cool. Now we have a quadratic to solve. After expanding, we have a quadratic to solve. We factorize the quadratic. And we have h plus 8, h minus 4 is greater than or equal to 0, right? If that's the case, then we're going to similarly again draw the graph. We realize that the value in front of the h is positive, which means that the graph has to be smiling. The roots are -8 and +4. So we need to find where it is greater than 0. Looking at the graph, the values for greater than 0 is anything less than -8 and anything greater than 4. So that's our answer. We just write down h is going to be -8, including -8, that's why I have the square bracket, and going all the way down to -infinity. And another set of solutions is starting at 4 and going up to positive. Okay, so starting at 4, going up to positive infinity. That's why we have to be very careful of square brackets and round brackets. It is okay also if you're not comfortable with this notation to write it in inequality form. We're going to be like h is less than -8 and h is greater than 4. H is less than or equal to -8 and h is greater than or equal to 4. Writing that also gives you the marks. You don't have to write it in this notation. Now, this question is about cubics and roots, right? So for this, the question has this cubic and says it has these 3 roots, right? It has these 3 roots, right? 5 minus x, 5 minus k, 5 and 5 plus k. And wants us to find p and k. Now, if you ever hear a cubic equation in pure maths, it's asking you about the products and sums of roots, right? So the first step is that you're going to remember that if we have three roots of a cubic equation, then if we multiply all the roots, we're going to just get the negative of d over a. So the first step we have is that we multiplied all the roots they gave us, which is 5 minus k, 5 minus k, 5 and 5 plus k. When we multiply them together, we're going to realize that we get a quadratic, a simple quadratic, which is there's no actual k value, there's only k squared. There's no k term, there's only k squared. But we equal that to 105. Remember, for a cubic, it goes a is in front of the x cubed, b is the negative 15, c is the p, and d is the negative 105. Right? So when we solve this equation, we have k can be plus or minus 2. We now have values for k, and we just need to find value for p. Find the value for p, we're going to look at the sum of pairwise products. So if we multiply each root and add them together, we're going to get c over a. So in this case, it's 5 minus k times 5 plus 5 minus k times 5 plus k plus what we have not multiplied yet, which is 5 and 5 plus k, right? Remember, these are all the roots, and we're looking at the sum of pairwise products. So now we are told that that's equal to c over a is 1 and c is p. So now we have this simple equation. Again, this is why I recommend having the calculator. Now we have k being plus or minus 2, right? Plus or minus 2, when you square it, you get 4 regardless of what, if it's plus or minus 2. So now we have 75 minus 4 is equal to p. That means p is 71. So now we have the values, right? We have k can be plus or minus 2, and p will be 71. Any confusion with this question that you want me to clear up? Okay, good. Good, okay. This, I don't have a YouTube channel. However, this is recorded, and New Jamaica Foundation will be posting it. I don't know where they'll be posting it, but I know that they will have access to it and will be posting it. So in the group, I'll ask the director and know where they'll be posting it, and I'll tell you it, okay? Okay, so this one now is one that I've not covered yet, which is the principle of mathematical induction. This one is a very difficult topic for a lot of students because it makes no sense to them. It makes no sense, not that it's hard to do, they just don't understand why they're even doing it in the first place, like why these steps exist. The question that they give is oftentimes just a divisibility question. They say, here's a function, prove that it's always divisible by some other number, right? And they give you 7 or 9 marks depending on the difficulty. For a question like this, it's 7 marks because it's really simple to just follow the steps. If it's 9 marks, you can expect a much more difficult question that will oftentimes have more indices rules. So to start it off is that they said that it's divisible, right? Divisible by 6. The first step you should always do is test the base case. If it says that n is any natural number, that means n, the first natural number is 1. So we're just going to plug in 1 and see if they are truthful. When you plug in 1, is it divisible by 6? So we have 7 to the power of 1 minus 1. So that's 7 minus 1, which is 6. 6 is indeed divisible by 6, right? That makes sense. So it's true for the base case. This alone is giving you some marks. So just do the base case. If you don't understand the question, do the base case, get some of the marks at least, right? Now, step 2 is where the first confusion happens for students. We're going to do an assumption. We're going to say, you told us that if we plug in n, it will be divisible by 6. So I'm going to assume you are true. I'm going to believe you for now, and I'm going to see if I believe you, what will happen to me. So you're going to replace n with k, right? And you're going to say f of k is equal to 7k minus 1. We're going to assume divisibility by saying f of k is equal to 7k minus 1, which is 6 times a, where a is a positive integer. Why did we do that? We're saying that if we plug in any value of k, right, any natural number, then it needs to be equal to 6 times some integer. This means it's divisible by 6, right? That makes sense. If it's 6 times 2, that's 12, which is divisible by 6. If it's 6 times 3, it's 18, which again is divisible by 6. So we're just saying that 7k minus 1 is, we're going to assume that it's always true. It's 6 times some number a. You get a mark for that. Again, these are just, so we did that's a mark for base case. We get a mark for making an assumption that what they said is true. And the second to last step, which is step 3, is induction. This is where the actual math part comes in. We're going to say, okay, I believe it for f of k, right? I believe it for when it's k, but what about when it's k plus 1? So we're going to plug in k plus 1. We're going to have 7k plus 1. We need to remember the indices rules. I know that this will be 7k plus 7 to the power of 1, right? Now, whenever you have a division, mathematical induction question, and you require yourself to have indices, you're going to replace the index with what you had for your assumption. So remember we said that 7k minus 1 is equal to 6k. We said, yes, that is true. Believe. Don't fight me on it. Just know that, yes, I said it was true. That means the same thing is here. 7k will be replaced with 6a plus 1. Look at that. You realize that 7k minus 1 is equal to 6a. That means 7k is equal to 6a plus 1. Cool, makes sense. Now that we have that, so replace the 7k times 7k to be 6a plus 1. Now we need to keep expanding and reducing until we have something that is divisible by 6. So we have 6a plus 1 times 7. We're going to multiply everyone here. So 6a times 7 is 42a, plus 1 times 7 is 7. We have 7 minus 1 gives us 6. And look at that now, right? 42 and 6 are both divisible by 6, right? If we factor out 6 outside, we have 7a plus 1. If a is an integer, which we said it was, then 7a is an integer, right? 7 times an integer will be an integer. And if we add 1 to an integer, it will still remain an integer. So that means 6 times some integer. We don't care what that integer is, but it's 6 times another integer. And if it's 6 times an integer, then you know that means what? F of k plus 1, f of k plus 1 is divisible by 6. And now the final step is to have the conclusion. The conclusion is literally a mark that you need to have. So if you end it here, you don't get all the full marks. You need to have the conclusion, which says, by the principle of mathematical induction, 7 to the n minus 1 is divisible by 6 for all n in the set of natural numbers. So now for this question, right, I know that it is a topic that gets a lot of students, like, that gets to a lot of students. So I have to ask, is there any issues that you have with this question? Yes, the conclusion, you absolutely have to write the conclusion. In fact, you don't even need to write anything else but the conclusion. So imagine you get the world's most difficult divisibility question about principle of mathematical induction, right? Imagine you get the world's most, it says 20 marks. It's incredibly difficult. You could just write the base case, right? As in, if it's in the question, it's so difficult, you cannot do it. Write the base case, write the assumption, skip out the induction, do the conclusion. So yes, oftentimes the conclusion is longer, but believe me, all you have to say is there's only 3 parts to the conclusion, right? Saying you did it by principle of mathematical induction. So just literally just say, I did this by principle of mathematical induction. The statement that you gave me was true. 7n minus 1 is divisible by 6 for all n in the set of natural numbers. And then the third part is ensuring that it's put into one sentence. You could, if the teacher writes a longer sentence, they're getting it right still. What's important is that you said that I did this by principle of mathematical induction, and the statement that you gave me at the very top is true. At first seeing this topic, well, this topic is asked every other year. So it's asked every other year, and maybe sometimes it's asked 2 years in a row. But yeah, you definitely need to practice this topic. Again, it's only one question, and it's usually a divisibility question. So the syllabus says they need to have the ability to prove things. This proof can take the form of mathematical induction, or it can take the form of counterexample, and it can take the example of direct proof. Was it asked last year? I don't think so. I don't think there was a question last year on it. So will it be this year? Probably. But I'm telling you, this is actually a really easy topic. If you just follow the steps. Base case, assume, induction, conclusion. If the question is hard, okay. Okay, so that's that part about if f of 1 is true, then f of 2 is true, and so on is this induction conclusion, is that between the induction and the conclusion. If you write that, we found that the base case is true, and every number after the base case, which is 2 and 3 is true, and so on. All of those will give you your mark, I promise. The only thing that's important is that you repeat the question, as in the statement that they said, which is 7n minus 1 is divisible by 6, and said that I did this by principle of mathematical induction. The teacher probably replaced principle of mathematical induction by saying that if f of 1 is true, then f of 2 is true, and so on. That's probably what they replaced it with. But both give it correctly. Okay? Fancy, I didn't hear that. Is that a question for me? Okay. So any issues with mathematical induction, and do you require me to actually go through more questions like this specifically? Or we're like, mathematical induction is fine. Run over this question again. Okay, no problem. Okay, no problem. So it says that we need to prove that a function 7n minus 1 is always divisible by 6, given that n is a natural number. Because it says prove something as divisibility, we just need to know summation problems. Okay, no problem. Can do that as well. So it says we need to prove that f of n equals 7 of n minus 1 is divisible by 6 for all n in natural numbers, right? We need to start with the base case. We're going to say, okay, the first natural number is 1, right? Natural numbers are counting numbers. The first natural number is 1. So when we plug in n equal 1, do we get an actual answer? I promise you this is the hard one. It doesn't really get harder than this, but I'll look at even more then. So I plug in 7 to the power of 1 minus 1. We get 7 minus 1 equals 6. 6 is divisible by 6, right? So that means this is true for the base case. When n equals 1, it's true. Now we need to do the assumption step. That's step 2. We're going to say, okay, I believed you, right? I believe that what you said in your question was true. F of k is divisible by 6. So we're going to say f of k, we're going to replace n with k and say that is equal to 6 times a. The reason we did that, right, is that we're saying that 7 to the k minus 1 is a number that's divisible by 6. That means it's 6 times any integer. Think of it like this, right? If I tell you that a number is even, then it's really just 2 times an integer. 2 times 3 is 6, which is even. 2 times 1 equal 2, which is even. So if I'm saying that it's divisible by 6, then it's 6 times some number a. I'm going to say, okay, I assume that is true. So you got 20 marks at least, right? Which is the base case and the assumption. If you can't do the question, still do those parts of the question. Then then the next step is induction, right? The induction is about, okay, I believe you for k. Now, what if I believe you and test out k plus 1? Yes, so if they said whole numbers, well, you see, I assume I don't think they've ever asked whole numbers specifically. They've asked, they've said it's usually natural numbers. Like, think off the top of my head, I don't think I've heard them ask something like that, natural numbers. But if they did say, yeah, I don't think they ever asked anything else. But if they did ask for whole numbers, you should start with 0. To be fair, the base case, I could also start with 3. In theory, I could also start with 3, right? Because if it works for 3, it works for 4, 5, 6, 7, 8, 9, and 10, and all the way up, I know it also works for the things below me as well, which is from 1, 2. But people usually start from the first possible value, right? So oftentimes it will be 0 or 1. If it says non-negative integers, it starts at 0. Cool. So for the induction now, right, we plug in k of k plus 1. We have k plus 1, and we need to ensure we know the index rules. The induction question is where you're going to be flaunting your index rule skills. So it becomes 7k times 7k, 7 to the power of k times 7 to the power of 1. This now, 7k, right? This 7k, we have to remember in our assumption here, where we said 7k minus 1 is equal to 6a. That means that 7k is 6a plus 1. Realize that we just transposed. So 7k is replaced with 6a plus 1. We multiply by 7, because we still have to work it out. So that 7 times 6 is 42a, plus 1 times 7 is 7, minus 1, we get 42a plus 6. Instantly, you realize that 42a plus 6, both of those numbers are divisible by 6, right? We have 6, open bracket, 7a plus 1. We remember that we said that a is an integer, right? A can be 1, 2, 3, 4, all the way up. And if a is an integer, then 7 times a has to be an integer. And then 7 times a plus 1 has to also be an integer, right? Which means that this entire inside section is an integer. Differentiation, no problem. 6 times m now, right, is divisible by, so if we replace the entire bracket with m, we have 6 times m. M is also an integer. So that means that 6 times an integer would also be divisible by 6. So now the last step is write a conclusion. Just tell them that, yes, all the work that I've done, I am correct. All that work I've done, I'm telling you now that what I've done is correct. So by principle of mathematical induction, the question that you stated is true. 7n minus 1 is divisible by 6 for all n in the set of natural numbers. So somebody said I need to do a hard induction question. They also said that I should do a summation question. Do the alpha beta gamma thing? Okay. Okay, I can do that as well. So okay, so we have topics that you want me to cover specifically. You see, induction doesn't really get much harder, at least not on K. When you do unit 2 and go to undergraduate, that's when you realize that, oh, induction can be difficult. It can be incredibly difficult. So now I'm looking for what you guys would consider difficult questions. Induction. Induction. Okay, okay. Okay, so the hard one. This is a hard one. However, the calculator is expensive, but trust, it's very useful. It's especially if you plan to do math beyond just CAPE. Like if you know that undergraduate will be requiring you to do math, like you're going to become a computer scientist if you're going to become an engineer, you're going to need an even stronger calculator eventually, but this will get you through undergraduate. So for example, can you say therefore proven for n equal a set of natural numbers? No, you can't say that. You can't, as in if you can add it to the conclusion, like I said, by PMI, this is divisible by 2, hence proven for n is in section of natural numbers. Oh, you want to not, okay, you might not want to, you don't want to say that 7 of n minus 1 is divisible by 6. You do have to say that part. You have to repeat their question. If it in the mark scheme that you do, I'm not sure, but I've never seen somebody complain about it. So now, is it allowed for us to use that type of calculator? Yes, it is a allowed calculator. You're not allowed to have a programmable calculator, and this is a non-programmable calculator. So it is allowed. Will CAPE eventually make it not allowed when they realize that it's an amazing calculator? Probably. But you know, have to fight against it anyways. Okay. Somebody said a difficult question. This is not a CAPE question. It is CAPE level, right? CAPE can, in theory, ask it. Will CAPE ask it? Probably not, because it's a pretty difficult question. Okay, so it's also a summation question. That's why it's difficult, because summation questions are difficult on average. So it says that we're summing. So it says that we are summing these values. So we're summing 1 over r times r plus 1 times r plus 2 from r equal 1 to n. And we're saying that left-hand side, when we're summing up to n, we'll always get n times n plus 1, n times n plus 3 over 4 times n plus 1 times n plus 2. So now, wait. Oh, sorry, that's 2 different questions. We're doing the second question, this one. This question, we're not doing the first one, this question. So the first thing is that we need to do the base case, right? Which is n equal 1. So plug in n equal 1, right? The left-hand side says 1 over 3 plus 1 times 3 minus 2. That's 1 over 4, right? Now look on the right-hand side. When we plug in n equal 1, we're going to get 1 over 3 times 1 plus 1 equal 1 over 4. So the left-hand side and right-hand side is correct, right? They equal the same thing, which means that it's true for the base case. Cool, no issues with that part, just the base case part. 1 mark, complete. Okay. So, yep, the teacher will definitely teach us this stuff, and I don't think CAPE will ask a question this difficult. They can. Will they? You know what? Maybe because I remember my year, the questions that they asked were very different from what they asked in the past. So maybe they'll choose to be more unique this year. So the next part is the assumption case, right? We're going to rewrite what they told us and say, okay, I believe I believe you. Whatever you said is true, so I assume it is true. Yeah, your teacher will often give you different ones, and that's okay, right? Because it's basically the more difficult questions. But if you look at CAPE, actual past paper questions with CAPE, they're on average easier than what a teacher will give you. So now we have the assumption, right? So this section is just the assumption, right there, assumption. And they get a mark again. So you got 2 marks already, and you haven't done anything difficult. Now this is where you have to separate the mathematicians from the people who are trying. We have n equal k plus 1. This is where you're going to do induction. So the step is that we're going up to k plus 1 now, right? So that means the k plus 1 is going to be the summation of k that we found before, right? Plus the k plus 1 term. So we have the sum that we found earlier up to k, right? Plus the k plus 1 thing. So now we replace what we assumed, the summation up to k we found was k over 3k plus 1, right? So replace it here. We place it here, right? Now we need to have the k plus 1 term. So we're going to just replace this section, what we have inside the summation here. The r, we're going to replace it with k plus 1, right? When we do that, we realize that we get in the denominator 3k plus 4 and 3k plus 1. Now, wow, I skipped a big step here because I was teaching a singular person. So we have this, and we need it to be as a fraction, as in 1 fraction. So we're going to have smallest common denominator, right?
Can I come sit down, please?
So join, okay, joined. So when we have this part, right? So we reach an induction, we replaced the sum from the assumption, and we have written the k plus 1 term. The next step is to just move and transpose and expand and everything we can to these 2 statements so that we can get to the right-hand side over here, right? The right-hand side here. It's important to note that oftentimes we want to look at what we want to find. So we have n over 3n plus 1. That's what we want to find, right? So we replace, we put this into 1 fraction, and now we have a quadratic over this denominator. We factorize the quadratic. We have k plus 1 as one of the factors. We divide, we factor out the 3k plus 1 and divide it. And now we have k plus 1 over 3k plus 4. Right here is where some people might get stuck and be like, okay, this doesn't look at what I want. But it does, right? It does look at what you want. Because this bottom section, this denominator, right, can be rewritten to be 3k plus, we're going to change the 4 into 3 plus 1. Now we realize that this part, 3k plus 3, can be written as 3 outside and k plus 1 inside, plus 1. Now that looks exactly like what we want, right? This looks like n, which is k plus 1, over 3n plus 1, which is what we were trying to prove, right? So therefore, it's true for n equal k plus 1. Then you have your conclusion. Because again, I was teaching one person, I skipped a lot of steps and I was like, by, and then you know that P, M, I, and then rewrite the summation, is true for all natural numbers. Any confusion with this question? Any confusion? No? Okay. So all right, no confusion. Okay, great. So this now, so the regardless of what the question is, right? I always have to remember the same approach is it's important that remember pure maths is you getting as many marks as possible. It's also about you being as fast as possible. So you have to always, when I see the question, you know immediately what you're going to do. In this case, I see the question, I know that the first thing I'm going to do is base case. Okay, got the answer? Assume. Okay, got the answer? One more, okay, no problem, tell me what the request is. And then n equal, we'll do the induction part, which is n equal k plus 1. And then after you do some induction, that's where the difficult part is. But always remember what we're going to do is remember the same patterns. If I said the difference of two squares, ensure factor it out. If you see the perfect squares, factor it out. If you see what else could you see? If you see what else could you see? So if you see induction, for induction, if you see perfect squares, difference of two squares, like all those things, you need to ensure that you, when you see it, you just be like, okay, I'm going to break it apart. Okay, I'm going to expand it, stuff like that, right? And then after you do the induction, you should write your conclusion. Okay, so in the chat, people are asking for truth table questions. Okay, loci of points. Okay. Is loci of points still on the syllabus? Or is that on unit 2 syllabus now? I will check. Real numbers for binary operation. Okay. Truth tables, yeah. Algebra proposition. Does CAPE even ask you to do algebra proposition still? Like it's on the syllabus, but do they ask that? On the coordinate geometry. Okay, okay. Oh, like circles and planes and stuff. Okay. Okay, so let me start from the top then. So somebody originally asked for alpha, beta, and gamma. So we're going to start, no, somebody asked for differentiation first. So there's the first, right? Differentiation first. So guys, I've written down everything you guys have asked for, right? And I'm going in the order that it was, right? So differentiation, I have roots of an equation. Okay, I'm going to roots of equation first because I have that PowerPoint open. Not PowerPoint, that notes that I have for that open. So share the screen. I want to share. So look at the roots of an equation, right? The roots of an equation in AddMaths, you have to start with the AddMaths section. In AddMaths, right, we learned about the roots of a quadratic. We learned that if they have the roots alpha and beta, right, then the adding them will give us negative b over a, and multiplying them is going to give us c over a. That's that we learned in AddMath. We are going to look at an example. If we have f of x is being x minus 2 times x plus 5, right? We know that the roots are 2 and negative 5. But before we do that, we're going to expand it out. We expand it out, we have x squared plus 3x minus 10. Let's look at what we're adding. When we add the roots together, realize we get negative 3. That is negative b because b is 3 and negative b is negative 3. So now, what about when we multiply? When we multiply, we get 2 times negative 5 is negative 10, which is c over a, right? So this case, c is negative 10. So that means this is something that you should know from AdMaths. If you didn't do AdMaths, I did pure math. Congratulations, you missed out on 1 year worth of information that a teacher might just skip over because it's something that you should learn on your own, right? So that's quadratics. Now, we're doing pure math, where we no longer do quadratics for roots. We go all the way up to cubics. For cubics, we're going to have to memorize these things. The product is going to be the negative d over a. The sum is going to be negative b over a, right? So be careful not to mess this up, right? Alpha, beta, and gamma, which are all the roots. When you multiply them together, you will get negative d over a. When you add them together, you'll get negative b as in boy over a. And then remember the sum of pairwise products. This is when you have alpha times beta, then alpha times gamma, plus what it didn't have for alpha, which is beta times gamma itself, and I get c over a. So these are all things you need to just memorize because it's not on the formula sheet. It's just something that they're going to ask you, and they're going to have to just know it. If you don't know it, you can prove it yourself, but when you prove it, you're wasting time because you won't have the time to be proving stuff in the exam. It's better to just remember a lot of things, especially for trigonometry, right? So we're going to start with this. We're going to look at the AdMaths question first, which is this equation has roots alpha and beta. Find 1 over alpha and 1 over beta. Well, a is 1, b is negative 7, and c is 4, right? Well, you know that alpha times beta is c over a, which is just 4, because 4 over 1 is just 4. When you add them together, alpha plus beta, you're going to get negative b over a, which is just negative of negative 7 over 1, which is 7, right? Now it's time to answer the actual question they asked, which is 1 over alpha plus 1 over beta, right? So when you have 1 over alpha plus 1 over beta, the first thing you must do is turn it into a singular fraction. To do that, you're going to find the least common multiple for the denominator, which is alpha times beta. So multiply 1 over alpha times 1 over alpha, multiply that by beta over beta. For 1 over beta, you're going to multiply that by alpha over alpha. So this becomes beta plus alpha over alpha beta. That now, if you realize that is just alpha plus beta over alpha times beta. We know what each of these values are, right? Alpha plus beta is 7, and alpha times beta is 4. So now the final answer is 7 over 4. Any confusion with that part? With the roots of a quadratic and getting 1 over alpha plus 1 over beta? No issues? No issues. Great. Okay, so another one that they can ask is, okay, please tell me what is 1 over alpha, they can ask you this part only, right? They will start with this part. What you need to remember is that I continuously tell you guys, you need to remember any perfect squares, any difference of squares, stuff like that. So what you need to realize, right, is that this alpha squared plus beta squared is actually very similar to perfect square, right? Where if you had a plus b squared, well, that is just a squared plus 2ab minus b squared. So for this, right, they told me just this part, a alpha squared plus beta squared. Well, that means they only gave me this section, and sorry, this is not supposed to be plus, this is supposed to be plus. This topic is called the roots of equations. So then they only give us this part, right? So that means I'm going to realize that alpha squared plus beta squared is the same thing as alpha plus beta all squared minus 2 alpha beta. This is just from this equation, right? This is me transposing this equation. Then I have these answers. I have alpha plus beta, right? That's just 7, so that's 7 squared. I have alpha beta, which is 4, so that's 7 squared minus 2 times 4, which at the end of the day gives me 41. So this is ADMAT's part, right? Which is when you're using quadratics. Oftentimes, they will not give you quadratics. So this is more of this is more of just ADMAT type things. Of course, pure maths can ask this, but it's just the ADMAT region, which is quadratic. I'm looking now if I go through cubic. Okay, cubic. You're given this cubic, find the sum product and the sum of pairwise products, right? So the sum is going to be negative b over a, which is b is negative 6, right? Negative 6, you see that? A is 9, realize. C is negative 3, and D is negative 2, right? It's very important that I write this down at the beginning and then start doing your math. So for the sum, it's negative b over a, so that's negative of negative 6 over 9, that's 2 over 3. The product, right? Remember, the product is negative d over a, which is negative of negative 2 over 9, which is just 2 over 9. Then the sum of pairwise products is going to be c over a, which is negative 3 over 9, that's negative 1 over 3. Right? This is, the question will always have this part, which you're just going to do every time. Now, we're going to look at the actual, yeah. Okay, so whenever it does that, right, you need to remember that if it asks you for a new equation, you're going to find the sum of the product and the product itself, right? And give them that new equation. Make sense? Make sense? So let's do this example. This is not a CAPE question. This is a question that I made, I believe. So it says that you have this quadratic, right? And it has roots alpha and beta. Whenever it says it has roots alpha and beta, do not even attempt to try to find what alpha and beta is, because likely it's not a real number. It might be an imaginary number, which you will learn about in Unit 2. So it says that I need to determine the cubic equation, which has roots alpha squared beta, alpha times beta squared, and alpha beta. Okay, so that's the question. So the first thing we'll do is going to write down what A, B, and C is. A, B, and C are. A is 2, B is negative 5, C is 8. For quadratics, when you add them together, you're going to get negative b over a, which is 5 over 2. For product, you're going to get c over a, which is just 4. So that part is the simple part. You need to start with that. Now it says that it's a cubic equation, right? So that means we're going to actually have to find the new cubic equation with these new roots. So first things first is that we need to find, for the cubic, we want to find the sum of these roots. So remember, the roots are alpha squared times beta, alpha times beta squared, and alpha beta. So the first thing we do is that we realize that, okay, we're going to factor out in this section, we're going to factor out alpha times beta. We're going to get alpha times beta, right, multiplied by alpha plus beta. Okay, so then alpha, beta is on outside, alpha plus beta is on the inside, and then we add alpha beta again. So this becomes alpha times beta is 4, alpha plus beta is 5 over 2. Okay, trigonometry and plane geometry. I don't know if there's time for all those different topics, but I'll definitely try. Alpha beta now, right, is 4 again. When I add it, when I use a calculator, I'm gonna answer, get 14. So we have found the sum of the roots for the cubic. So before we even begin, you know that the sum right here is going to be 40. You see that? You see that? So what we need to do is fill it in as I go along. Now it says to find the product. Multiply the product to get alpha, multiply all the roots, we get alpha to the 4 times beta to the 4, we know that this is the same thing as alpha times beta all to the power of 4. I'll get 256. So that's a product for the cubic, right? The product of the roots. Now we need to find the sum of product. This is when oftentimes the question gets quite difficult. So we multiply them individually, so it's pairwise. This gives us alpha cubed times beta cubed. I'm not sending the recording. I am recording, however, and it's sent to New Jamaica Foundation, and they will be dealing with the whole like sending to students type deal. So now the multiplication, so we multiply each of these, right? And this is just us playing with factorization. So we have, right here, we have alpha cubed beta squared plus alpha squared beta cubed. And what's important is that we realize that, oh, we can factor out alpha beta all squared, and we get alpha plus beta in the bracket. At the end of the day, we just want alpha times beta stuff and alpha plus beta stuff, because we can't do anything else. We don't know what 1 over alpha is. We only know alpha times beta and alpha plus beta. When you get the equation that only has alpha times beta and alpha plus beta, you plug in all those values and get your answer from your calculator, plug it into the new equation. So at the end of the day, you're going to find the sum of product, the product, and you're going to just write it and tell them that this is the new cubic equation. Cool. The next thing that someone asked for is that was alpha, beta, gamma. And then truth tables was the next one that somebody asked. Or did they ask something between? Oh, differentiation. Differentiation questions can get really difficult, to be honest. Differentiation. Differentiation. Okay. Okay. So differentiation. For differentiation, right? It's just you memorizing every rule that they have. Every rule in question is oftentimes the ones you learned earlier in additional mathematics. This is the notes for that, but that part is not important. We are just looking at okay. So for differentiation, the questions only get really difficult whenever it's worded and their job is to interpret the words. So it says a ladder is 10 meters long and it is leaning against a wall. Okay. The bottom of the ladder is sliding away from the base of the wall at a rate of 4 meters per second. Okay. Determine the rate at which the top of the ladder is moving down the wall when the bottom of the ladder is 6 meters from the base of the wall. Okay. So start with this is that the ladder is against the wall. If you draw that diagram, you realize that, oh, you know that's the right angle triangle. Once you can draw a diagram, you're going to realize that, and when you realize that it's a right angle triangle, you're going to realize, okay, we're probably going to need Pythagoras, we're going to probably need sine, cosine, stuff like that. So that's the first thing I did, I drew it, right? And then now it says the rate at which x is falling, right? The rate at which the base is falling, so that's dx equal dt. Dx dt, which is the bottom of the ladder, right? The bottom of the ladder is falling. It's falling at a rate of 4 meters per second, which means that dx dx dt is equal to 4, right? Now, it says they want to find out the top of the ladder. That's dy over dt. We do not know dy over dt. That's what we want to find. So dy over dt, dx over dt. The first thing is that when you don't realize that there was no equations in here, right? There was no actual equations, but they give you a triangle. And once you see triangle, you're gonna have to just like know Pythagoras is playing in this question. So remember they said that the ladder is 10 meters long. So regardless of what it's falling, this ladder has to remain 10 meters long. It won't stretch or expand, right? So now we have the Pythagoras, the equation x squared plus y squared is going to be equal to 10 meters squared, right? And then now, oh yeah, sure, why not? Okay, so then we have Pythagoras, right, which is x squared plus y squared equal 10 meters squared. Now we need to differentiate and get an answer. So we're going to differentiate with respect to x. We have now y equal the square root of 10 squared minus x squared. So we have a half. We're going to put the half in front because that's the rule of differentiation. So put the half in front, keep what's in the bracket, and minus 1 from the power, so that's negative a half now, right? And need to multiply it by what the derivative of the inside is. The derivative of 100 is going to just, it's a constant, so it's just going to be 0. And then the derivative of x squared is 2x. Cool. Up to this point, this makes sense. So the derivative dy dx is equal to a half, open bracket 10 squared minus x squared to the power of negative a half times negative 2x. No issues there so far, right? Now, the next part is that we earlier said that what is the rate when the bottom of the ladder is 6 meters away from the wall? That means x is equal to 6. Plug in x as being 6. Plug in x as 6, we get 8. Right? This is us plugging. Who's this? Okay. Okay, so we're plugging in x as 6 and we get our current answer of 8, right? That's what the rate of change of dy to dx is. But we don't want that, right? Remember the question asks us for dy dt. That's what it asks us, right? So we need to use a chain rule. dy dt is going to be dy dx, right? Multiplied by dx dt. If you look at it, right, it's kind of like a fraction where dx at bottom, so if you do that, right, it'll cancel. To be very clear, these are not fractions. You can't do this exactly, but you can think about it like that. So then we have dy dx, dx dt, right? This part was found to be 4. dy dx, when we plugged in x, right, in the math that we're doing over here, we got negative 3 over 4. We plug in our calculator, we get negative 3 meters per second. So what this is saying, right, is that when x is 6 meters away from the wall, so x is 6, right, and it's still sliding at the rate of 4 meters per second, y is falling down at 3 meters per second. Right, 3 meters per second. One of the topics that is not taught to you in Unit 1 is implicit differentiation. But it's taught to you in Unit 2, but I learned it in Unit 1 because it makes a lot of things easier. So I won't be doing it because like you don't need to learn it until Unit 2. And then now, question that they would often ask, that if they're asking a differentiation question, they're going to often ask you to do with parametric equations of a curve. So for the parametric equation, they're going to say, okay, x is equal to 5 cosine of theta, while y is equal to 2 sine of theta, right? And they're saying that they want to find dy dx. Well, the first step is to differentiate each of these with respect to theta. So that's dx over d theta is equal to 5 times the differentiation of 5 cosine theta. Remember, the differential of cosine theta is negative sine theta, right? So it becomes negative 5 sine theta. For 2 sine theta, dy d theta is going to be 2 cosine theta, because the derivative of sine theta is cosine theta. Now we have two things. Remember the chain rule then, right? Is that we want dy over dx. We're going to have dy over d theta, because this cancels this. Realize that this cancels this, right? D thetas cancel each other. And so we have dy d theta is 2 times cosine theta multiplied by d theta over dx, right? D theta over dx. Remember, we found dx over d theta, but we want the reciprocal of that. So we're going to say 1 over negative 5 sine theta. Now we have negative 2 over 5 cosine over sine. Just to be clear, this could also be written as negative 2 over 5 and have tan theta in the denominator. That would also be an acceptable answer. Tan theta. Because remember that tan is sine over cosine, but this is cosine over tan. Cosine over sine. So that's differentiation. Remember, so all the rules of differentiation are here, right here, right here. And everything is just you applying these rules back and forth. The only time a question ever gets difficult is whenever it's worded, right? Why wouldn't it be cut? It could also be cut, right? So scrolling down to here. This is an acceptable answer. Negative 2 over 5 with tan theta in the box in the denominator. Or you could have negative 2 over 5 with cot in the numerator. Right? So you could leave it as cosine over sine. You could have tan in the denominator, or I could have cot in the numerator. Anyone that you feel comfortable having, okay? For me, I'll probably leave it as it with tan, but that's because because this is module 3 and not module 2, where module 2 is about trigonometry, and I need to be using cot relatively in module 2. But since it's in module 3, I wouldn't be troubling that. You would have to bring it back to something. Yes, except on your calculator. My calculator, I think my calculator has cut. I think my calculator has cut. Don't quote me on that. But yeah. Truth tables. Truth tables is a problem. Interesting. So so whenever it has a worded question, your job is to always do the following. Write the things in mathematical notation. So I have dx over dt being 4, right? I have x equals 6, and I have dy over dt being unknown, right? The next step after that is to write any equation. This case, I wrote x squared plus y squared equal 10 squared. But to be fair, there are other equations that I could use. Like, if you, for some reason, felt overly ambitious, I wanted to use sine rule or cosine rule, which are CSEC topics, and I wanted to introduce it here, then go right ahead. It would be more difficult. It would be more time consuming. But suppose I want to prove that you know other ways of doing it, it would be perfectly acceptable, and they would have to mark you and give you the correct. And if you get the correct answer, they have to give you the full marks. But I use Pythagoras because that's the person that came to mind. If you say a right angle triangle and you don't think Pythagoras, then I think that's a problem that you need to fix. Like if you say right triangle, always think Pythagoras. So somebody said truth table and algebra proposition. Okay. I'd have to struggle to find questions for algebra proposition because I don't think Kip has asked that in a while, right? Usually they ask you do it either by truth table or algebra proposition. So I'll look for that question about algebra proposition. It's okay. 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 So okay, so this is a truth table. If it will often, if it's on the exam, it will be the first question on the exam because it's the first topic on the syllabus. Logical reasoning, logics and reasoning. So this is P, this is Q. It's saying that P can be true or false, Q can be true or false. When it's happening, right? When things are happening to P and Q, what is P implies Q, or if P then Q? There are numerous ways to read this symbol, right? And what it really means is that it should only be false. The only time P implies Q is ever false, right? Is if I said I would do it and I didn't. So it would be the case that P happens. So if P, then Q must happen, but it didn't happen here. This is the only time it would be false. Otherwise, it's always true. Make sense? Similarly, for Q implies P, the only time it will ever be false is if Q said that I would do something. I would do it, meaning I would do something, but then P did not do it. So that would be the case of Q said they would do it, but P did not. So this is false, right? So that's T, T, T. So far, that makes sense what implies mean? Any issues with that? No issues. Okay. Okay, great. So then the next part is that this symbol is and. the way that I remember which symbol is and or is if you give somebody a thumbs up, right? It's and. Thumbs up and. Okay. And then similarly, the or would be this symbol. So it says that what is P implies Q and Q implies P. So it's just the and of both of these. So this is true because true and true is true. Similarly, true and true is true. Otherwise, it has to be false. Right? So false. And that's kind of it for truth tables. Like truth tables don't ask for a lot. Then now it says that hence state whether or not the statement Q implies P. So is this and this logically equivalent? Justify your answer. It's 2 marks. The first thing you have to do is answer the question. State whether or not they're logically equivalent. No, they are not logically equivalent. Right? 1 mark. Now you need to justify your answer. Why did you say that? Well, it's simple. Look at both columns, right? Look at both columns. But look at both columns, they do not match. So you just have to tell them the column, right, of Q implies P does not match P implies Q and Q implies P. Does not match. And once I said that, so the first mark is you telling them no, it's not logical equivalence. And then the second mark is you explaining your answer of yeah, it's not at all. No, they said somebody said algebra proposition. I just don't think Cape asks that anymore. It's on the syllabus. I know it is, right? I'll just one more of these questions first and then look if I can find any one of those. So scroll down to here. All right. This symbol now is the not symbol. So it's saying not Q, right? So that becomes false, true, false, true. Cool. Now it says not Q, so this right here, and P right here. So we're ANDing these 2 columns. So that's, and if it has a false in there, we already know that it's going to be false. So this is false, this is false. Now we need to find out if this is true or not. So this is true and true will be true. False and true will be false. Cool. Now we have this section, right? So this is here, and this is here. This now is the OR symbol. So OR means that it's only false if both of them are false. So in this case, we have false or true will give us true. We have true or true will give us true. We have false or false will give us false. And then false or false will give us false. Now it says state whether these are logically equivalent. Well, this is this section and this is this section. And are they logically equivalent? No. No, they are not. Why are they not? Because this column has false, true, false, true, false, false, but this one has true. You realize that true right here? That doesn't match this section, so that means it's not the same. It's not logically equivalent. And that's the explanation that you're going to give them. That was 2022. Yeah, I'm all the way back at 2019, and I can't find algebra proposition, and I don't think Cape asks that without asking logical, like the truth table. So they don't seem to say, okay, do something by algebra proposition. Instead, they would say, if they do have algebra proposition, they would say solve, prove something either by algebra proposition or truth table. And oftentimes the students pick truth table instead because it's less issues with it. Someone also said to take a quick look at real numbers. And so by real numbers and binary operator, right? Thank you. Glad I can be helpful. So for this binary operator, right? It says it's closed in R. So closed in R, first things first is, what does closed mean? Well, in binary operators, right? Close refers to closure. Closure means that if I put a real number as X and Y, my answer has to 100% be a real number back. I cannot enter a real number and get an imaginary number out of it. So let's look at a simple example first. So we mean that, you know, the square root of X, that's not closed in real numbers, because if I enter the real number of 2, I get this, the real number of 4, right? The square root of 4 is equal to 2. By the way, Cape doesn't, like, if you have the square root of something, you don't say the -2 because they often want the principal root, so it's a positive value, unless like there's a reason for getting negative value. But the main point I'm making here is that the real number, if I send the real number -4 instead now, and I say the square root of -4, you realize that this don't make no sense. Like, you can't get the square root of a negative number. This is actually an imaginary number called 2i, right? And so that means that the square root operator cannot be closed in real numbers. That means if I enter a real number, I might not, it's very possible, there is a possibility that I might not get a real number out of it back. Okay? So now it's asking us, in this case, we have a new operator called star. When I use star on 2 numbers, prove to me that the real number will always, that if I enter 2 real numbers, I will always get a real number back. I won't get any imaginary numbers. So there's 2 ways to prove it. I don't do the first way, which is if you enter, like, just give an example of x equal 2 and y equal 2, y equal 3, and then just like work it out and show that, oh, no matter I get at the end, if I get number 5, oh, it's like closed in real numbers. Cape seems to accept it, but it's not an actual proof. Like, this is not a way to prove something. So I will not be teaching that method because I think it's very bad. I don't think you should ever really learn it, especially if you're going to do math in undergraduate, because it's not a proof that is appropriate. So to prove it, you're going to say, let x and y be real numbers, right? Then we have x star y, and that becomes x squared plus y squared. Then now we just need to tell them that recall the square of a real number will always be real. So that means that this will be a real number and this will be a real number, right? So because x is a real number and y is a real number, when I square them, they will still be a real number. There's no real number I can square and get an imaginary number, right? Square 2, you get 4. Square -2, you get 4 still. Like, you still get a real number. You don't get any imaginary numbers. And then the last part is saying that addition is closed under real, which means that if I'm adding two real numbers, right, I'm going to get a real number back. There's no way to add two real numbers and get an imaginary number. So that means that this final answer, right, will be a real number. Hence, proven. So let's go from top again, right? Instead of actually doing it the way that some teachers teach, is just plug in X and plug in Y, which is not applicable at higher level math. I don't fully know if CAPE allows that method. They probably do, but I can't be sure. For this method, however, they do, which is that we make the assumption that X and Y are real numbers. We say, okay, X star Y, remember the star is not multiplication, it's an operator, it's a binary operator. We're going to say, okay, that becomes X squared plus Y squared. Remember that squaring a number, squaring any real number will always give us a real number. So we tell them, okay, so that means that X squared is real and Y squared is real. And then when they add two real numbers, you get a real number out of it. So this is really a explanation question instead of an actual math question. It's you explaining that when you add real numbers, you get a real number. When you square a real number, you get a real number. Stuff like that. Oh, okay, I have that as well. Okay, so I want to look at binary operations. That's what they said. Okay. Binary operations. Binary. Okay. Okay, so binary operations is a pretty big topic. However, there's not many questions that can be asked because it's very repetitive. It's just asking you to prove something. So imagine they give you a function f of x is equal to 3x plus 2. That's not binary because you realize that there can only be one value of x. Well, a binary operator would be if I had like f of a comma b is equal to 3a plus 2b. But they wouldn't use f, they would use star. Okay? Binary operation will take two inputs. That's hence the word. So the properties of binary operator that it tests is closed. So for closure, right, is that if I say that the things that I enter, A and B, right, are in some arbitrary set A, this can be real numbers or whatever, when I apply it and get C from the answer, C must also be in that same set. C will never deviate from that set. So for testing for closure, right, imagine we say to test that A star B, which is the modulus of A minus B, is closed under the positive integers, that's Z plus. We're going to say if A and B are positive integers, so we're looking on the right-hand side, the modulus of P, like the modulus of anything, will always be positive. So star is closed under Z plus. And then you could give the example, which is 8 minus 12. 8 minus 12 is -4. The modulus of that is 4, which is a positive number, so it's always closed under positive numbers. Now, the next question is saying A star B is equal to the square root of A squared plus B squared. And that is closed under rational numbers, Q. Rational, remember that rational numbers is a specific set of numbers. So it's rational numbers, right? Is wait, why am I explaining rational numbers to my students? So I for this is ask a is question instead of proving it. So it didn't ask to prove, it's just asked like a yes or no question, right? So it just need to find an example that causes an issue. So 7, so I have 7 and I have b as 1. When you get it, you get the square root of 50, which is like ongoing. Similarly, we could just looking at the square root of a squared plus b squared. It may be rational if a squared plus b squared is 2, right? Like if the square root of 2 is not rational, it's irrational. So star is not closed on the rational numbers. So a and b, right? Maybe 1, which is rational, but then I get the square root of 2 as a final answer, which is irrational. Okay. Now, commutativity is when you're just able to switch both sides. So if you have a star b, that is equal to b star a. But this one way is to just plug in the numbers. So if you have 2 and 3, work with the left hand side, I get 17, work with the right hand side, I get 17. You say, okay, it's commutative. Another way is to write it as x star y equal y star x, and then work on the left hand side, right? Work on the left hand side and work on the right hand side simultaneously. Whenever I reach on both sides and realize that, oh, this left hand side actually looks like the right hand side, then yep, they're commutative. For associative or for commutative, you could also just use logic and reasoning. Hold on. If I say that a star b is 2a b plus a plus b, right? And I'm saying, is this commutative? Well, I can also say, since this is only multiplication and addition happening, there's no division or stuff like that. I can just immediately know that, yes, this is commutative because addition and multiplication are commutative operations. If it had subtraction in it, right, then it would not be commutative, right? But there's only addition and only multiplication. So it has to be commutative. The similar process can be worked with associative. So associative is when you have the brackets around it and you realize that, oh, I could do the other set of numbers first instead of doing the first bracket. So this bracket could be worked first, or I could work this part of the equation first. But this is the same thing as where you work on the left-hand side, right? So I have x star, y star, z. I work the y star z first. I have a final answer on the left-hand side. I do the same thing for the right-hand side. Now, this time I work on the x star y first, right? When I work it out, I reach this part, and look at that. The left-hand side is equal to right-hand side, and so I know, okay, this is associative. Another way that I could say it is that since star only has multiplication, since remember that right here, right? This is it, right? The star is only multiplying things. I can tell them since it only has multiplication, it has to be associative because multiplication is associative. So if you have an operation that is only multiplication and ask if it's associative, you know it has to be because multiplication is itself is associative. Distributive is when you just can do the distributive law, which is the whole in the bracket, out of bracket thing. Similarly, it's you just plug this one using plugging the answers is probably easier. Is it something that you should always do? It depends on how you feel. Identity is when you say, okay, A star E is the same thing as E star A, which will always give me the answer of A. If you think about it, think about addition, right? It would be 3 plus 0 is the same thing as 0 plus 3, which is the same thing as 3. So 0 is the additive identity. If you look at multiplication, 4 times 1 is equal to 1 times 4, which is the same thing as 4. So 1 is a multiplicative identity, right? Up to this point, any confusion? No. Okay. So for the inverse inverse, right? The inverse is when you have A and you're saying when I multiply by a value, I will get the identity. So A star will depend, sorry, A inverse will depend on A. If you think about addition, right? Addition, right? That would be A. If you think about addition, right? I'm saying that A plus some value A to the -1. To be clear, A to the -1 in this case does not mean 1 over A. It doesn't, right? It means the inverse. It's very important to acknowledge that the notation is different. Is equal to the identity. Remember, the identity of addition is 0, so it's equal to 0. So in this case, if A is 2, A inverse will be -2, right? And similarly, if A is 7, -7, then A inverse will be +7. So you realize that A inverse depends on A, as in A inverse is not like identity where the identity is always set in stone like 0 or 1. Instead, A inverse will be some value dependent on A itself. Cool. Somebody said where's the topic up here? The topic, real numbers, truth table, algebra proposition done, undercoordinate geometry, loci. Is that the last thing that somebody said? Trigonometry and plane geometry and vectors. Wow, those are actually a lot of topics. Okay. Okay. Okay, so the break for us is at 1 and resume at 2 and continue until before 4, as in when 4 o'clock reaches, the class ends. So that would be the last things I'm covering. Coordinate geometry, trigonometry, plane geometry, and vectors. So I'm going to cover plane geometry. I'm going to cover plane geometry and vectors in the second session and try to cover loci, which is coordinate geometry now. Yeah, okay. That seems like a good approach. So coordinate geometry. So I'm going to look at the note that I created. Okay. So for coordinate geometry, we're looking at circles specifically. So we first have to see that CAPE doesn't consider only, well, all questions will be circles, but you have to learn about the larger idea of conics. Conics is when you have a circle or an ellipse, basically that. So a circle is defined as the set of every single point that is of distance r, the radius, from the center. And from that information, right, you can learn the equation of the circle. So if you remember, right, we're looking at the distance. So imagine a circle with the center A and B, right? Now, we know that it will be all the points X and Y, which have a distance of R. So the distance between 2 points, A and B and X and Y, will be X minus A squared plus Y minus B squared divided by, the square root of that is equal to the radius, which is the distance. That way we get X minus A squared plus Y minus B squared is equal to R squared. That is one equation of the circle that you will need forever and ever. Now, that's just one of the equations. This was the deriving equations. CAPE will not ask you to derive it. They just assume you should know this, right? And there are other forms of the equations. So that's the standard form, but you also have the general form. If you expand this out, you realize that this can be written as x squared plus y squared minus 2ax minus 2by plus a squared plus b squared minus r squared. That means this entire section is a constant, right? This has constants in it, and this is just s squared and y squared. there is also the way to represent it, a circle, without X and Y. As in, sometimes we are looking at a graph, and you know you have the graphs being horizontal and vertical lines. Not all the time do you need the horizontal and vertical lines. Sometimes it would be better if we could draw it on a graph that just had circles instead, right? So look at this. Realize that, so you have the traditional graph paper, which is the boxes. So it's so amazing to draw like straight lines, curves, stuff like that, right? But because a circle would just feel so much more comfortable if all the lines were, instead of forming rectangles, they formed circles themselves. So then the way to define a point, which is 3, 3, would instead be the angle. So the angle is pi over 4, which is radians. So it would be the angle multiplied by the length, not multiply, so it'll be the angle here in the, what you consider the y part of the point, and the length of the line in the x part. However, it requires you to not, CAPE does not ask you to have any understanding of polar coordinates. What it does ask you is parametrics. And so with parametrics, it's whenever you have sine and cosine, and you don't have x and y put together in the same place. So for conics, which is a way to just describe ellipses and circles and any forms of like curves, they can be presented as using 2 equations. So imagine I say x equals sine t and y equals cosine t. T is just a variable like x and y, but it's hidden, right? It's a parametric, which means that we no longer have x and y. Remember, you usually have like y equal 2x. No, instead I'm saying that x is a value, y is a value that is depending on a new variable called t. So the question that CAPE often asks is for us to move from these pair of equations to just one equation. And the way that we do that is that we're going to always use the same identity, which is taught in module 2, module 2, which is sine squared plus cosine squared is equal to 1. If I don't memorize this identity, I don't know what to tell you, man. Like, this is an important identity. So for that, right, if we said that sine, so the question gives us this part, and the question says find the Cartesian equation. You're going to say, okay, sine squared plus cosine squared is always equal to 1, which means that x squared plus y squared is equal to 1. So that, like, the sine squared t is from here, because this is x is equal to sine t, so sine squared t must be equal to x squared. Right? That makes sense, right? Any issues with that? With us moving from Cartesian, from parametric equation to Cartesian equation? Any issues with that? No. Nope. Okay, great. So now we're going to look at a more complicated example, because that was just us like learning that parametric equations and Cartesian equations exist. Now they instead say, okay, look, x is equal to 2 plus sine theta and y equal 9 plus 6 cosine theta. Now we need to still do the same thing, which is sine squared theta plus cosine squared theta is equal to 1. So sine squared is going to just be x minus 2 squared. You see that? Like, move the 2 over the equal sign and squared. So that's x minus 2 squared plus, now cosine is going to be y minus 9 divided by 6 all squared. Now that's equal to 1, right? And next step is to just remove this 6 from inside. So this becomes 36 outside, 36 outside here. So I realized that wasn't like hard. It's the same steps every time. Recall the trig identity, sine squared plus cosine squared being 1. Substitute sine and cosine for their Cartesian counterparts, and just simplify. Now there's a thing that there's the family of curves that CAPE will ask. CAPE will just be like, is this a circle? Like, prove that this is a circle. To prove that it's a circle, you want it to look like this. You just want to prove that the denominator are the same. It's r squared. Because if they're not the same, then it's an ellipse. The ellipse where A and B are not the radius, they are the foci, which is just how much is it stretching. Remember, an ellipse is like a circle is a specialized ellipse, right? But the ellipse might be shaped so that it's shaped like an egg, right? For example, imagine it's shaped like an egg, but a circle is perfectly round. So that would be when B and A are the same, then if A and B are the same, then it's a circle. If it's not the same, then it's an ellipse. And it's important that you're able to tell when they're one or the other. Now you're asking about loci, right? To find intersection point between a circle and a straight line, we need to solve the equation simultaneously. We'll denote the equation of the circle as C. So that means C is just the equation of the circle, and L is the equation of the straight line. We're going to just substitute the expression for y from the linear equation, which is a line. So we're going to get the equation for the line and put that into the equation of the circle. This substitution will always give us a quadratic equation in the form of x. Now this way it gets pretty easy. You just solve for x. And once you get x, you're going to plug in the values for x that you found into y, and that will give us two intersection points, one intersection point, or no intersection points. If you get one intersection point, that line is tangent. And it's very important to remember that tangents and normals are questions that CAPE will ask. So now you have to think about tangents and normals to a circle. It will tell you that you need to find the tangent and normal to the circle at any point. The rules, the steps to do that always remain the same, right? You're going to say the tangent to a circle is perpendicular to the radius, right? Therefore, the slope of the tangent is the negative reciprocal of the slope of the radius. So now that becomes so confusing, like, okay, so that means the first step is to find the gradient of the normal line. We find the gradient of the normal line, right, by just having the point on the circle and the point that is at the center. Find the gradient, like in physics, the change in y over the change in x. If you are finding, that would give you the normal, right? But if you want the tangent, you're going to just times by -1 and flip the answer. So if I have half, your answer should be, so if you have half for your gradient, your answer should be -2 now, right? So let's do another example. If you have -2/3 as your gradient, you're going to flip it to be -3/2 and change the sign from negative to positive, so you're going to get 3/2. Got that? That made sense? So if you get your answer as 5, and you need, so if your normal is 5, right? And you need a tangent, you're going to say -1/5. Cool. Then you just need to write it in the equation. So now you have the gradient, right? You're going to write the equation y minus the point that they gave you equal the gradient they found times x minus the point that they gave you. So remember, the point has x and y. This is a way to have that. Remember that it's the same thing as y equal mx plus c, but this is without finding c. This is just the gradient and the point that they gave you. When you do that, you're going to just simplify your answer to get it in the form y equal mx plus c, and I'm going to find an answer, okay? So I'm going to look if I can find a question on coordinate geometry for loci, because how often does CAPE even ask that? CAPE, good school, uh, Yeah, they don't really ask for loci specifically. Yeah, the loci is usually covered in unit 2, mostly where they ask you for imaginary numbers and loci. So loci that I assume you're talking about in this case is just circles and lines. So I'm going to look at the last pure math paper that was released, which is 2023, and looking for coordinate geometry. Okay, grabbing this. So zoom. They did in 2022. Okay, 2022. I'll look for that one then. When 22. Asking about local. Proof, show, trig. Okay, so again, this is just like coordinate geometry, not like difficult loci question type. So let me go to whiteboard. Okay. So the question says, this is a circle, right? And they want the center and the radius for the circle. So I would recommend, there's two ways to find it. It's one of the ways is to complete the square, and the other way is to just know where they are. So yeah, I think I'll do it the way that I usually do it is by completing the square. So we're going to have x squared minus 10x. Something should be here, but we don't know what it is yet. Plus y squared plus 4y. Something should be here, but I don't know what it is yet. Equal 5. So really, I put the x's together, the y's together, and put the 5 on this side. Now, I want to turn this x into a perfect square, right? In this case, remember that for a perfect square, if I have x minus a squared, we're going to have x squared minus 2ax plus a squared. So in that case, right, if I'm saying that negative 2ax is the same thing as negative 10, then a has to be 5, right? That makes sense, right? So that means what should be here is 5 squared, right? So that means that this can be written as x minus 5 squared. Now, it's important to note that I put a 5 here, right? I put that 5 here. And that's not what it can do. It can't do something like that, right? I need to do it to both sides. So now I need to also add 5 squared on this side. Because if I add it here, I have to do it on both sides of the equation. Similarly, I'm going to do the same thing for the y section. So now, for y, I immediately know that to complete the square here, I need to have plus 2 squared. Hold on. In that case, you get y plus 2 all squared, right? And if we add 2 here, we need to do the same on this side. So that becomes plus 2 squared. Cool, cool. So now the left-hand side, right-hand side becomes 34. And just from here, you can want to tell exactly what this circle has. The circle has a center at 5, -2. That's from here. So the 5 and -2. How we change the symbol, right? We change the sign. And this, remember, this is the radius squared. So it has the radius of square root 34. Any issues with this question? Made sense? Any issues? I'll assume no. Okay. The next part of the question then says, okay, determine the equation of the tangent. So determine the equation of the tangent. So the tangent to the point 2, 3. To do that, we're going to find the gradient. So m is going to equal to the change in y over the change in x, right? So in this case, we're going to have the change in y is going to be 3 minus 2. This is not writing properly. 3 minus -2. So this 3 comes from here. This -2 comes from here. And that's divided by, keep the same progress, which is 2 minus 5. This gives us 5 over -3. Now, it's important to note that this gradient is the normal. And I need the tangent, right? So I need the tangent. To get the tangent, then I need to flip and make this positive. So the tangent is going to then become 3 over 5. So that makes sense. So this was negative, so it becomes positive, and I flip it. Then the next part is I'm going to say, okay, that means the equation of the tangent is going to be y minus 3, which is from here, is equal to 3 over 5, multiplied by x minus what we have here is 2, right? You know the expectation is that you're not going to be like this, you're going to actually simplify it down. So it becomes y equal -3 over 5 x plus, why am I doing this? I can just get my calculator and do it. Okay, so I'm sorry, hold on. Okay, so that's 3x plus 9 over 5. Question is done, right? Okay. So then that's another question, right? Where it says determine the tangent to the circle at that point. So we find the gradient of the normal. Then we have to flip it for the tangent. And then we find the actual equation because we need them to have y equal the gradient. Oh, I'm I'm sorry, hold on. I made a mistake. This should be equal, and I put a minus by accident. So this is not minus, this is positive. Yep. Okay. Yep, okay. So then you get the final answer being a linear equation. Okay, ask for a line. And in the question. Question, answer anything else after that? Nope. After that, so that's what second questions usually look at. They usually just ask you find the center and radius, find the tangent, find the to find the radius, find the center, find the tangent, find the normal, is the intersection with the line, stuff like that, right? That is what I see as a loci question. Like, is there a question differently? Oh, okay, I see what you're saying. No, there is a question after that. Okay, I see what you're saying. So, oh, okay, okay, okay. I'm sorry. I thought that was a loci question. No, it's not. So, going here, this. Okay, okay, there we go. This is what you're talking about then. So a point P, a point moves in the XY plane such that it's the same distance on the point A as it is from the line x minus 3. Determine the equation of the locus of P. Wow. Okay, see so many marks with this. 5, 6. Okay, 6 marks. Okay. 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 Okay, so for this, the problem is that it's worded, right? Whenever a problem is worded, you need to first interpret what it says and move it from words to mathematical equations. So let's do it. So it says the first section part, first part of it, right? Says P moves, it is the same distance from this as it is from the line x equal 3. Okay. So the way that I do this, right, is right the first part of it, which is it's asking a distance question. Remember how we find distance. So the distance between the distance. Do I need to? Okay, I'm sure it's zoom in so I can write it off. So the distance between A and P. That's the first thing I do, because like it says that they're doing a distance question. So the first thing I'm gonna do is just write an equation for that distance. In this case, that is going to be the square root of x squared, nope, sorry, x minus 1 squared, right, plus y minus 2 squared. So in this case, right, this is just the distance between A and P, right? And I also mentioned the distance it has from the line x equal 3. What is the distance from P to x equal 3? 6 minus. Oh, okay, yeah. So the distance is going to be, I think if I draw diagram, draw the graph, it becomes clearer. So we have this, right? We have the line. Nope, wrong way. We have the line x equal 3. Is that okay? And we have some kind of point right here, call it P. We want to find the distance here, right? The distance is going to be this X value. So 3 minus X, same difference. X minus 3 minus X, it shouldn't affect anything. Okay, it could be on the other side, right? So 3 minus X is one that you chose to use. So let's use that. So that's 3 minus X. Cool. Now we have two things, and they said these two things are the same. All right. So that means if they're the same, I'm going to just equate them. So that becomes the square root of X minus 1 squared plus Y minus 2 squared is equal to 3 minus X. All right. Square both sides. Oh, you know this alpha work? X minus 1 squared plus Y minus 2 squared is equal to 3 minus X squared. Is that unbelievable? I want to work for real for 5 marks. But you have to this. Oh no, it's not 3 quadratic, it's 1 quadratic, promise. So let me start expanding. So it's this is gonna be canceling, right? So this gonna becomes X squared minus 2X plus 1 plus Y squared minus 4Y minus plus 4 is equal to X squared minus 6X plus 9. Yeah, okay. So first things first, the reason why it's not 2 quadratics, like it's not a really difficult question anymore, is because this cancels here, right? And we're going to write this minus 6X is going to go on this side and become positive 6X, which leaves us with 4X. This Y squared is going over here to become negative Y squared. And then this minus 4Y is going over here as well to become positive 4Y. And then this 4 plus this 1 is 5. We'll bring it over here to become negative 5. 9 minus 5 is going to be 4. Right? And then we're done. So equation is this. I would also say X is equal to negative 1 over 4 Y squared plus Y plus 1. So look at that, ready? So what I'm saying, right, is that the question from the beginning said it's the same distance from A as it is from the line X equal 3. So you have two things. You have the distance from A and have the distance from P, right? And you're going to just equate it. The equation for the loci is not always written in terms of X. It's just easier to write in terms of X. If we wrote it in terms of Y, which we usually do, is that we would have like y equal like square root and like a lot of other things with it, right? Which would just look ugly. You could write it in terms of y, because you do the the quadratic formula, right? But you don't need to, because you do get an answer. This is an equation, and therefore the answer is like complete. I would leave it here. If you want, like it's not gonna affect anything, right? Because you could put it all on one side. But the important part is that when you have it, there's nothing I can divide anymore. There's nothing I can subtract anymore. So you only have the x, you only have the y squared, you only have a y, you only have a constant, and you have a x, right? It would have been great also if you had y equal like x squared plus x plus 1. Like this is just an example. You might get the answer like this, right? This is also acceptable because remember it asked for an equation. If we had instead x squared plus x plus 1 equals 0, this equation will only have two values, right? There's only two values for x. But we're saying that P loci can exist on multiple, like a lot of different points. I think a good way to show that is by having, look at a graph. Yeah. Okay. I'm going to try to show on a graph. There's we have x equal y squared plus negative 1/4 x squared plus y plus 1 x equal 3 and the point 1,2. This makes sense? I'm up. I'm not. I'm trying to get a graph up. Okay. Yep. This looks good. All right. So then I need to share that. Look at this, right? This is me explaining loci now, right? So this, before I even do anything else, we have this point, the green point right here is A, right? This is the point A. We're then saying that this is the point P, right? And we also have x equal 3 being this line. We're saying that the point P is traveling on a line. It's a very fast line. Okay, so let me see. So P is traveling on this line, right? The loci is this red line. The loci is this entire curve. It's not an equation with 0 in it, which is 0. It's an entire curve, right? And we're saying that P travels along this line, and at every point on this line, distance from P to A, the same as distance from P here to this x equal 3 line. Make sense? So that's why it's not equal to 0, because it's actually a actually a line or a curve that we're creating. Make sense? Okay, good. So whenever they ask you for a loci, you're going to get an actual equation. And that equation is just saying that every single point on this line will be such that the distance from this point P and A is the same as distance from this point P to x equal 3. So it's not two values of P, it's every single point that can travel on this line. Cool. So that's us taking a break until 2, where then I was told to talk about plane geometry and vectors and trigonometry. Okay, no problem. All right, you guys can go and come back, eat lunch or whatever that is. Bye. Okay. So I was asked to look at some geometry and vector plane questions. For this one, it's from the K paper and it says, determine the equation of the plane that passes through the point 0, 2, -2, and which is perpendicular to the vector 3i plus 2j plus 4k. The first part is that a lot of things in this section is just you memorizing. One of the things is that you have to memorize this equation. Memorizing. Okay, so there should be a bracket around this. So this is an equation for a plane. This is one of the many equations you can have, where R is a variable, right? And then A is a point on the plane, and then N is a normal to the plane. So with that, right, you're going to realize that they're going to realize that there's multiple other equations, but you're going to have to memorize each of them. Oftentimes, this is one that you're going to use most, but you might need to use the others or derive the others yourself, right? So by variable, I mean that this is X, Y, and Z. This is a point defined by X, Y, and Z that we don't know yet. We don't know what that point is yet. Minus the point that we do know on the curve, on the plane, which is 0 to -2, right? Right here. Then we're going to do the dot product with the normal, which they said is perpendicular. Remember, the normal and the perpendicular is the same thing. And the normal is 3i plus 2j plus 4k. So rewrite that in this form, the vector form. Since it's in brackets, you have to do the in bracket section first, right? And if we're subtracting vectors, we're going to have subtracting component-wise, meaning we're going to subtract x minus 0. We're going to have y minus 2, and then z minus -2, which is z plus 2, right? And we're going to have the dot product. The dot product with 3, 2, 4. Remember that dot product is just you multiplying and then adding everything component-wise. So it becomes 3 times x minus 0 added to 2 times y minus 2, and then add to that 4 times z plus 2, and that's still equal to 0. Because remember up here in the equation, we said it's r minus a all dot product with n equals 0. We do that, we have now 3x plus 2y plus 4z is equal to -4. We'll do that with an equation, right? What is this equation? It's similar to how you have an equation that has like y equal 2x, where you have the variable y, the variable x, but now because it's three-dimensional, a plane, imagine a book, right? If you have a line, it's in 2 dimensions. A plane is in 3. So you're going to have x, y, and z. Now, the next question, so that's another question we asked you to just get the equation. The equation is written in this form. There's other forms you can write the equation in. Now it says determine the angle between a vector a equal 3i minus 2j and the x-axis. Okay. So I did a quick diagram, right, of the vector that they're talking about. They say it's at 3i, which means on the y-axis, which is the same as the x-axis, it goes over by 3, and then there is negative 2j, so it goes down by 2 away here, right? And then the vector A moves from the origin to that point. So now we have this red arrow indicating that vector. I asked for the angle with the x-axis. The angle with the x-axis is then going to be theta, right? So then, if you remember, theta is going to be tan inverse of y over x. This is something that you can actually find out for yourself. We oftentimes, you're supposed to just know that theta is equal to the tan inverse of the gradient. Y over x is the gradient in this case, right? So we're going to have tan inverse of negative 2, which is the y section, that's a j, over 3, which is the x. And when you do tan inverse in our calculator, we get negative 33.69 degrees. That makes sense, right? It's negative, so going this way, they count positive. That's how they did it in C-Sec math, and we continue that process here, where anti-clockwise is considered positive. Now, since this is going negative, it's going to be negative 33 or 33 degrees below the x-axis. Both are correct, okay? If you had only 33, you would not get answer correct. Well, depending on if on how Cape wants to clarify it, right? Because it's important that the direction that it is, because it could have been 33 above, but you're clarifying that it's 33 degrees below. Also, you didn't have to give it in degrees. You might have wanted to give it in radians. Both are fine since it did not clarify which you should give it in. However, if you're doing trigonometry, you should oftentimes give it in radians at the pure maths level. But it doesn't affect if they didn't tell you which angle type they would like. Now, I'm going to look at one more plane question. It says that we want the vector equation of a plane that passes through the point 1, 5, negative 1. And that same plane, and it is also perpendicular to the vector 2, 4, 3. Remember, right? Remember that we had this equation earlier where we have the variable r minus the point that is on the plane, dot product with the normal vector. The normal vector is the one that is perpendicular, and A is the point that it passes through. We're going to expand and bring it on both sides. And we're going to have R being the variable still. The dot product with the normal vector is equal to the point that it passes through, dot product with the normal vector. We're going to do that now, right? So the normal vector, when we're dot producting, when we're doing the dot product, we're going to have 1 times 2 plus 5 times 4 plus negative 1 times 3. Add that together, we get 19. I'm going to keep the left-hand side as is. Why do we leave like this versus when we had x, y, and z? Because they said they want the vector equation. This is the form that the vector equation takes. If they ask for the Cartesian equation, they want the one that we did earlier with the x. So this equation here is the Cartesian equation. And then you also have the vector equation. Vector equation is one that has the I, j, and k. So this equation is saying that R is some point with a x, y, and a z. And when you dot product it with the normal, you're going to get 19. Now it says, hence, determine the coordinate of the point in the plane at y equal 3 and z equal 1. So we're going to recall the equation that we got, which is r dot product 2i plus 4j plus 3k, and that's equal to 19. We're going to replace the r with x, y, and z. Remember, r is just a point, the point at x, y, z. We don't know what x, y, z is, but it's that point. So it becomes 2 times the x plus 4 times the y plus 3 times the z, and that's equal to 19. Now they told us that y is equal to 3 and z is equal to 1. We're going to plug those values in. I'm going to simplify down to get 2x equal 4 and then x equal 2. Then at the end of the day, we need to give them the actual answer. So the point is 2, 3, 1. So it's saying that this is a plane that exists. And if we look at the plane and we look at y equal 3 and z equal 1, so at that point, it's going to be at the x coordinate of 2. This is the final question that I found that I wanted to do on coordinate geometry, which is, it says that they have defined a line with parametrics, right? Remember earlier we did parametrics, which is that you don't have a singular equation like y equal 2x. Instead you have x is equal to t, and then y is equal to sine of the same t. So this case, they have it in parametrics, and they also define another plane. They define a plane in the Cartesian equation. They said that these two intersect, find the point of intersection. Okay. The first step is that we're going to look at the plane and realize that it's x, y, and z. If they're intersecting, then they have the same x, the same y, and the same z. So we're going to replace the x, y, and z in the plane with that of the line. So x is being replaced with 2 plus t. The y is being replaced with 1 minus 3t. And then the z is being replaced with 4 plus t. And that's still equal to 12. You plug this into your calculator to find out what t is. We find t is -1. Now it's a point of intersection. Remember, a point has x, y, and z. So even though we have t, we need x, y, and z instead. Send the link. There you go. So now we'll find t, right? We need to actually find x, y, and z. We have x, y, and z from the line, and this is in respect to t. So we have to plug -1, which is t, into the equation for the line. We're going to have x equal 2 plus t, which is 2 plus -1, which is just 1. Y is equal to 1 minus 3t. That's 1 minus 3 times -1, which is 1 plus 3, which is 4. Same thing for z, we get 3. Now we have a point at 1, 4, 3. Out of all these questions, was there any issues that you want me to double check and like show over? Any issues with any of these questions? Okay, no. I wanted to show hmm. Mhm. Okay. So, waiting for the screen share. Okay. So the the questions that Cape asked are quite repetitive for that for vectors. It's the same equation over and over. But I think it's important to start knowing concepts and memorizing rules. So if we have two vectors, two lines, these are lines. So this line is really just saying that, okay, it passes through this point, right? It passes through the point 1, 1, 2, and it has this, basically says that it has this gradient, right? So then if it's saying, okay, are these two lines parallel? You're really asking, are the gradients the same? Remember, this section in the bracket here is basically the gradient. So we look at it and realize that the first one has a direction of 3 is to negative 2 is to 4. The second one is negative 6 to 4 is to negative 8. We realize that we can, this gradient is technically the same here, where this one is 2 times this one and negative. So it's negative 2 times R1. And since they have the same direction, then they are parallel. That made sense? Any issues with parallel lines in 3 dimensions? No issues. Okay. Now, whenever the lines are not parallel, they will have an intersection. The intersection will be when you equate them to each other. When you equate them to each other, you realize that it will only that when you do that, the parameter part, which is in this case lambda and this case mu, will have unique values. If they don't have a unique value, then they don't intersect. So the thing is, 2 lines that are parallel can intersect or it can not intersect. You know, in 2 dimensions, a line that is non-parallel will have to intersect. But in 3 dimensions, that's not true. If you think about it, right, you can hold the fingers up together and then try to intersect them, right? But then move them apart from each other. Realize that there is a possibility that because it's in 3 dimensions, they are skew, which means they do not intersect and they are not parallel. Do they have the example again? Okay, so let's look at this, okay? We're just looking at if it's parallel or not parallel. So this one is 1, and this one is negative, right? So when you look at here, it's not the same. It's not the same ratio, which means that it's not parallel. The same thought process can be done for each of these. I want to look at this. The angle between any two lines in the dimensions will be cosine of theta equal d1 and the dot product d2 over the product of their magnitudes. So this is going to be it's going to be especially important whenever a K question asks you to find the angle of something, then that means they're asking you to use this equation. And we know that if these lines are perpendicular, which means that they from a 90-degree angle, then cosine of 90 will be 0. So if cosine of theta is equal to 0, right, you have a fraction here that's equal to 0. Then really it's the same thing as just having the top denominator, the denominator being 0. So if the dot product of two vectors is 0, of two vectors, two lines is 0, then that means the lines are perpendicular. This part is not important. This part is not important. No, about this undergraduate. Okay, so I wanted to no, okay. No, no. No, 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 no. Okay. So I wanted to show one more question about vectors and geometry, which is on a Cape paper, where it asks, so I have the whiteboard and going to get the question that I saw. Okay, so we just looked at angles, right? The angle here. So, 1 second. So we're going to have the equation I had in the beginning, right? Which is cosine of theta is going to be equal, in this case, to u dot product v over u v. But I want to show something about this. Given that a line is parallel to the vector v u, so there's a line that is parallel. So let's imagine the line goes like this. And it says that the vector v is normal to the plane. So there is a plane like this. And so the normal looks like this, right? So it's a normal v, this is u. The issue is the angle between the line and the plane is not the angle between this normal and this line. If you realize, you're going to notice that if we just look at it sideways only, so we're looking at it, so this is 3 dimensions, we're going to just go into 2. I'm going to have the vector the vector v, which is a normal to the plane, so the plane is here. The plane is here, and then you have a line here. Realize that if we do this, we're going to get the angle here. But we don't want the angle there. We want the angle between the line and the plane. So any answer we get here, we need to rewrite it to be 90 minus whatever angle we got. Make sense? That was understandable? On why we need to have 90 minus theta? Any issues with that part? Okay, we're good. Okay. Okay, if that's the case, then okay, so we're going to go over here. We're going to have a plane. The plane is in 3 dimensions, so this is a 3-dimensional drawing. Now let me see if I can do it better. The 3-dimensional drawing is this, right? So it's three dimensions. And so the normal is 90 degrees to the plane, which means the normal is like this. Cool. Normal to the plane. Now, because it's normal to the plane, and we have a line that does so because we have this line now that goes like this. So this is a line that we want to find the angle with. And this is the normal that we found. This normal and this line, we want to just say, oh, the cosine of the angle between them is theta equal the normal dot product with the line all upon the magnitude of each of them. There's an issue, however. This angle that we found is not the angle between the line and the plane. That's because the angle we found is, we're going to turn this 3D drawing into 2 dimensions. If we do that, we're going to have the normal line, which means that it's 90 degrees to the plane. So this is the plane. Now we're looking at it sideways. We're not looking in 3 dimensions, we're just looking at the sideways part. And this is the normal. and they're going to have a line passing through the plane. If I look at that, you realize that if we find the angle between the normal and the line, we'll get this angle. You notice now that that's not the angle we want. We get this angle, right? But that's not the angle that we want. We want the angle between the line, this line, and this plane. So we want this angle. And since we want that angle, and we know that this entire thing is 90 degrees, this angle is going to be 90 minus whatever we found. Good. So that's what's important there. That's the only thing I need to go and say on that part. And then the cosine of theta is just plugging in values. No problem. The cosine of theta is just you plugging in values. So all of these parts is you memorizing equations and plugging in their values. I think the best way is to simply show each equation. So I'm looking for the picture I had. Equation. Yeah, this was the one. Okay. Okay, okay, great. So then, sharing this part. So for this, there are multiple ways to define a vector, similar to how you have multiple ways to define a plane. It's like how you have different vectors, different ways to define a line where you can have y equal mx plus c, or you can write it in like y equal yp equal y minus yp equal m times x minus xp. You can write the plane in multiple ways. If you have if you have the point on the plane, so the point on the plane A and the normal to the plane, then you have this form. This form can then be turned into the normal form. If you realize this D here is really just a point on the plane multiplied by the normal. So these are interchangeable. This is what is very important to know. You're supposed to know it at the back of your hand. And then there is this one that you don't need to know exactly. This, nope, don't need to know that one. So the one I need to know is the equation whenever I have a point on it and the normal. So take a picture, write it down, ensure that you know this one to a T. And then I also earlier saw the lines. This is the one that you will always see, right? Which is the line is defined by A, which is the point on the line. And then B, realize that B is technically the gradient, where it's just like, oh, the direction that it's going. And then lambda is just a parameter, which means that if lambda changes, the point R on the circle, the point R on the line changes as well. The next one is this here. The angle between two vectors. The angle between two vectors, reminder is that it's the cosine of the angle is going to be A dot B over the magnitude of both angles. There is a sine version which has cross product. Cross product is not covered on the CAPE syllabus, but you will need it. But you won't need it until undergraduate, okay? So only cosine theta equal A dot B over the magnitude of A and B. It's very important that you memorize these equations. Is it on the what's it called? The formula booklet? I'm not sure. It's very important I also check if those things are on the formula booklet because I am not aware if it is. That's kind of the part that's important for this. You guys asked for coordinate geometry. I think that's everything, yes. Vectors in 3D, plane geometry, and they said trigonometry. Trigonometry is a pretty broad topic that covers an unbelievable amount of things. Okay, I know what to do. Okay. I think I'm finished with all the questions. What I'm going to do now is I'm just going to look at questions and tell you what you should be thinking about. Not actually solving them because I think at this point we're able to solve lots of questions. It's more about getting familiar with techniques. So with that, I'm going to look at one trigonometry question, then end. Okay, if that's cool. Okay, do we need to know the sum to difference identities? Sums to difference identities? The sum of angles in sine? No, that is on the formula sheet. So, but you will need to know other identities. Like most identities are not on the formula sheet, but you will need to know them. So I want to look at one trig question and like how I would go about solving it. And then end. So that's whiteboard this. Okay. So we're doing a proof of trig question. The first step is that you should start with the side that has the most things on it, or at least the things that can expand the most. In this case, it's the right-hand side. My teacher forced me to use the left-hand side. So even in this case, I'd use the left-hand side and turn into the right-hand side. However, you don't have to do that. So we're going to use the right-hand side and prove it. So to do that, so we're going to start with the right-hand side. And we're going to go by changing this to 1. The first step is that we look at the left-hand side, realize that there's no tans, there's no secs, there's no any of that. There's only sines and cosines. So that's 1 over sine, 1 over sine of theta minus, and then tan now is sine over cosine. So now my first step is basically complete, right? Which is that I change everybody to sine and cosine because no one on the left-hand side is a cosecant or cot, none of that. It's all sines and cosines. So that's what I'm doing. The next step is that we look on the left-hand side, realize that everything is one fraction. So we're going to change this to one fraction. To do that, we're going to have the denominator being, oh wait, sorry, that's a mistake right there. Secant is 1 over cosine, not 1 over sine. 1 cosine. Good. And now we're going to change to one fraction. We have cosine in the denominator. And we're going to have 1 minus sine in the numerator. Remember, this is still squared. So now we have completed 2 steps, which is turn everybody to sine and cosine and write as one fraction. The next step is to realize that this now only has sine. So let's expand the square. We're going to have 1 minus sine squared over, we're going to r square that. We're going to have that over cosine squared, right? This is cosine squared, but we know that cosine squared is just 1 minus sine squared. Okay, remember that cosine squared plus sine squared is going to be equal to 1. And if that's the case, then we can just rewrite cosine squared, this part, as 1 minus sine squared. Now, if you have learned anything from the class, is that whenever you see a perfect square, or a difference of 2 squares, you need to expand it. So I see the difference of 2 squares here, because this is 1 squared minus sine squared. So now, in the denominator, this is 1 minus sine multiplied by 1 plus sine. That made sense? As in, I saw 1 minus sine squared. I know that this is a difference of 2 squares. And immediately, I factorized it. Now you can see that this part, this 1 minus sine all squared gets cancelled by this. So this 1 minus sine cancels one of these. And if I am left with 1 minus sine all upon what's left in the denominator is 1 plus sine. So that's 1 plus sine. Okay, and that is equal to the left-hand side. Now I'm going to go over again and explain the thought process. The thought process is, we realize on the left-hand side, there is no secant, there's no tans, there's none of that. There's just sines. So we're going to change the right-hand side to be only sine and cosine. We realize that the left-hand side only has 1 fraction, not 2. So we're going to turn this into 2 fractions. Turn it from 2 fractions into 1 fraction. In this case, we have 1 minus sine theta all upon cosine. We have the square outside, so we're going to square the denominator and the numerator. Square the denominator, we have 1 minus sine theta all squared. For the denominator now, we're going to have cosine squared theta. But we already realized that we don't want any cosine because the left-hand side has no cosines in it. So there's no point in having this cosine squared. So we're going to turn the cosine squared into sine squared. So the cosine squared plus sine squared is equal to 1 is an identity that we are very familiar with from Pythagoras. And so we know that cosine squared is going to be equal to 1 minus sine squared. Cool. So now that part is substituted in the denominator. We then realize that this denominator is the difference of two squares. So we turn the 1 minus sine squared into 1 minus sine and 1 plus sine. And that now becomes 1. Now we can realize that one of the values in the denominator, this one, can cancel one of the numerator. And now we have 1 minus sine all upon 1 plus sine. Any confusion about that? No confusion, right? So my tips for doing trig questions is to notice patterns between them. So if you realize that everything on one side is one fraction, there's no reason for you to be working with multiple fractions on your side. So if it has one fraction, combine it by its one fraction. If it has a sign, you're going to need to try to get that sign. If it has a tan, you're going to need to somehow have sine over cosine. Okay? So those are my tips for trigonometry, vector, geometry, and all other topics. So yeah. One last thing is